All right, so the last class there, we looked at the volume and surface area of a cylinder. And now what we're going to do is kind of look at some of the other shapes that we were dealing with before, but we're just going to talk about the surface area. And again, the surface area, if you missed this morning, is the amount of squares needed to cover an object. So it's essentially how much wrapping paper would you need? Not if I wrapped a present, but if somebody else did, because I need like a whole roll. And I don't know how much tape. So it usually takes people in my family like 20 minutes to open a present because there's so much tape on it and paper covering it. Not that I do it on purpose, just the way it is. Now, a couple objects we've dealt with before is the prisms we're going to start with. And again, a prism is any object where the cross sections are all equal or can be all equal, which is a nice way of saying it's like slicing bread, where if you take the object and you slice it like bread, all the slices would be the same. All right, now, with the surface area of a rectangular prism, we have 2 times, but in brackets, so we're going to use some bedmas again, WH plus W, or LW plus LH. And again, our W is the width. This side here is the length, and always straight up from the bottom to the top, or the top to the bottom, is our height. All right, now the other object we have is a triangular prism, which again, I don't know if this formula is more complicated, but there's definitely a lot more letters going on here. So where we have B is our base, which we've talked about before, the distance along the bottom. Again, H is our height straight up. We have the length, and then we have W and S, which are the lengths of the sides. Now, they can be different because you can have a slanted triangular prism. All right, so on that note, we're going to find the surface area of the box below. All right, so here's our formula right here for a rectangular prism. And again, as I've mentioned, I'm going to follow all the same steps I've been following. But just different shapes, different formulas, that's all. And so I'm going to label my 12 here. There's my width. See, and I just match things up. There's my length. And there's my height. Now, this formula, again, surface area, SA, is equal to 2 times, let's see, WH plus LW plus LH. All right, so there's my formula. Now I'm going to substitute in. Now, this is why it's really important for me, and I think for you, to label your diagram of what's what, so that way when you're reusing this formula and we get so many variables, we don't mess up putting them in or put one in twice and miss one, that kind of thing. So here I have W times H to start off. All right, so W is 12, and it's time, so I'm going to put it in brackets, these two, and H is 6. All right, now plus we got L times W, which let's see, I look on my diagram, one's 4, one's 12. So I'm going to have a 4 times a 12. All right, then the last one here is L times H. So L again is 4, H is 6. So I'm going to have a 4 times 6. All right, there we go. So again, same steps, got my formula, labeled my diagram, substituted in, and now it's the math, the calculating part. Now this one, I got to follow bedmas. Well, I have these square brackets, so I got to do everything inside the brackets. But within brackets, again, you have to follow bedmas. And so there's no exponents, which is great. But we do have some multiplying going on. So I'm going to do 12 times 6 here. That's 72. Space there. There we go, 72. All right, then I've got plus 4 times 12. If I do 4 times 12 here, I get 48. Plus 4 times 6. Don't need the calculator for that one because I know that 4 times 6 is 24. Now, I'm still not done with the brackets here. Because I got the 2 out front here, that's multiplying. So now I'm going to have to do the addition. So I take 72 plus 48 plus 24. And end up with 144. All right, so finally, I'm done the brackets. And then lastly, I'm going to take 2 times 144, and I end up with 288. Now, just as I've done before, everything's measured in centimeters. But again, surface area is the amount of squares it takes to cover the object. So a little 2 for squared, centimeters squared. So again, even though it's a three-dimensional object, wrapping paper that goes around the object is squares. It's two-dimensional because you can lay it flat on the floor. Anything you can lay flat on the floor and it doesn't stick up relatively is two-dimensional. All right, so that's our box. Now, I need the other formula here. Let me see if I can copy this. Let me copy. Whoa, won't let me do that? I thought it would. All right, I guess not. Oh, here we go. Not doing it. All right, fair enough. All right, so now I get to the triangular prism. All right, so I am going to need that formula. Again, so I'm going to grab my formula sheet because I'm going to, again, post a formula sheet in the Google Classroom here today, probably right after class. But the formula for surface area, because this one's got a lot going on here. So we got B times H plus L times S plus L times W plus L times B. All right, now I look up and I want to match things up. I wonder if I can just drag this down, this whole thing. Let me see. I think I can. Whoa, no, it's not letting me do it. Oh. That might work. Oh, not happening. All right, fair enough. Let's delete that. Okay, so I have to match up. And this is the best part about having a formula sheet. I got to match things up to figure out, like, I got a lot of numbers here. Now, I do know that this 3 here is the distance from the bottom straight up. So that there is that's my height right there. And the distance along the bottom from one end to the other is going to be my base. All right, now the other thing we looked at with the triangular prism is the length of it, how long this triangular prism is. So there's my L. Now this side, this triangle is a little bit slanted. And so one of these values is the W and one of them is the S. So there we go. Again, when you have a formula sheet that I'm going to give you, you can line these up, match them up. All right, so now that comes to, I've got my formula, I've labeled my diagram, now it's substituting. All right, so now I'm going to substitute in. Now this one you got to be careful with, right, because there's so many variables. So I got a B times an H. So that's an 8 times a 3. All right, plus an L times an S. What's my L here? 15, that's the length, right? And my S is 5, so I get a 15 times a 5. All right, don't want to mess it up here. Then I got an L times a W. All right, so that's going to be a 15, and W is a 6. Okay. And then lastly, I got an L times a B. This L's involved, isn't it? 15 times, what was it again? A B, which is 8. Again, that's why I label my diagrams here. I don't want to forget. All right. Now it's Bedmas, right? Calculating. Well, brackets, nothing's going on in any of these brackets. We don't have exponents in these two formulas. That's a break, isn't it? All right, so 8 times 3, I know it's 24. 15 times 5, I don't know that one. I'll throw that in my calculator here. So 15 times 5 is 75. I definitely don't know my 15 times table here, so I'm going to have to do 15 times 6, and I get 90. And then lastly, 15 times 8, which is 120. All right, so again, following Bedmas. Lastly, I got to add all these up. So I take my 24 add it to 75, and then add it to 90. And this time I'm getting 309. Again, we're looking at all these measurements were in centimeters, and they were the amount of squares we need to cover up this box, or this whatever it is. Looks like kind of like a sub box or something like that. All right, now again, here's another triangular prism. Oh yeah, shift my formula over here. Perfect, that worked out nice. All right, so I want to determine the surface area of this triangular prism. So this one's a little bit different, but again, I got to match things up here. Let's see here. Again, if I was to kind of imagine putting this one on the ground, I'd say this is the bottom of the triangle, right? So then we go straight up. Well, that means that 6 there has to be my height. All right, now that distance along the bottom of the triangle is always my base. Oh, down here. So that's my base. All right, now, the length. Now, if I imagine this, it's a visual thing where you got to imagine this thing is sitting on the ground. 9's going to be my length. Now, the best part about S and W, they're interchangeable. They're just the slant heights. So one's called S because it is the slant height, and the other one's the other one, which I just throw in as a W. Just made that up. So it's part of our formula that's on our sheet there. All right, so I've labeled my diagram. I got my formula. Well, now it's time to do the substitution. Let's pick a different color here, separate it a bit. All right, so I got surface area is equal to, again, now that's where I got to look at my diagram, B times H. So B 16, H is 6. So I got a 16 times 6. All right, then I got an L times an S. Let's see here. L times S. L is 9. And S is, I said, was 10. Okay. All right, next up we have L times W. L was 9 again. And W is 12. All right, throw that in there. And then lastly, we have an L times a B. So we have a 9. And what's our B again? 16. All right, there it is. Put that in there. Okay. So next up, VEDMIS. Doing our calculating. The best part now is I got everything substituted in. I don't really need the diagram anymore because all it is the math now. All right, so my surface area is equal to 16 times 6. So I got to do my multiplication first, right? Can't add. So let's see here. 16, I have no idea what 16 times 6 is. 96. Okay. 9 times 10, I know that one. That's going to be 90. 9 times 12, though. Yeah, I don't know that one. So let's see. 9 times 12. 108. And then lastly, 9 times 16. Yeah, I don't know my 16 or my 9 times tables that high. 9 times 16, 144. All right. And then lastly, again, for VEDMIS, add all these up. So I take my 96, then I add 90, and then I add 108. I get 438. What was this measured in? This object, all the units were in meters. And again, we're talking about how many squares it takes to cover this object. So we get 438 squares, meters squares, because there's different sizes of squares. All right, so that's prisms. So we have our rectangular prism and our triangular prism. Now we got one more shape coming at you here. Where is it here? There it is. And that is the surface area of a pyramid. So we got a lot more, a few variables in here. This one's a little bit different where we have the surface area is equal to the A plus N times your BS divided by 2. All right, so now A is the area of the base of the pyramid. All right, and N is the number of sides. And our B is the bottom number, the length of the bottom part of the triangle, or the pyramid, sorry. And a height is always from the bottom to the straight up to the top. Okay, so let's see if I can, I can't move this formula. Let's I want to copy it. See if I can copy this thing. Oh yeah, there we go. Oh, it's not happening. All right. All right, so again, I'm going to write out the formula because we are finding the surface area of the pyramid below. Now, I've messed this up a little bit. There should be these little marks. And hopefully you remember what those marks are all about. But again, when I'm talking about this formula, surface area, we got the surface area is equal to the area of the base, plus N times BS divided by 2. Now, what was S? That was one we didn't have there. S is the slant height. So your height on a slant, where height H is straight up, S is your slant height, so it's on an angle here. All right, so to check this one out, let's see here. First off, area. Now you look at the bottom of our pyramid. We need to find the area and see how these little tickies are there. That means each side is the same, which means our base looks like this. So it's like you're looking down at your pyramid. All right, so we have tick, 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 tick. They're all worth 10. And in fact, what we have here is a rectangle, which most of you would call a square, but it is a special rectangle. All right, and so that special rectangle, let's see here. We have the area is equal to length times W, length times width. Now, in this case, the area of our, it's going to be, well, our length is 10 and our width is 10. That's easy enough because they're the same. And let's see here. Now, the area, 10 times 10, well, that's one I do know. That's 100. So there's one of my variables down. I got the A. Now, let's check out N, which is, let's go back up here, the number of sides. So number of sides here, we got 1 on the right, 1 up front, 1 back here, it's the left, and then 1 behind. So there's 4 sides to this pyramid. So N is equal to 4. All right, again, B, that's your base, the length from one end to the other. All right, and that's our B. Perfect. Whoops, made that a little bit of a mess. There we go, that undid it. And then S, now here's the tough part. S is our slant height. Now we don't have that. But I want you to pay attention in blue what we do have. There's our slant height. We have a little triangle in there. All right, where now this is going to be tough. We're going to use a little Pythagorean theorem here because all the way across our base is 10, and this is only halfway across, so that's a 5 there. Our slant height, again, is this blue line right there. And so what I'm going to have to do, that's a 5. Oh, that's bad. This is a 5 right here that I put in quotation marks, and this is our S that I underlined. All right, now, this is a right angle triangle. So, again, the hypotenuse is right across from our right angle. And so I have my A squared plus B squared is equal to C squared. Now, our one side here is 12, so I'll call that A. So instead of an A squared, I have a 12 squared. And instead of a B, let's see here, that's our 5. So I'm going to put that as 5 squared. And that's equal to S, our slant height, which is our C, our hypotenuse. So that's S. It's hard for me to write 5s and S at the. They don't look that much different, do they? Trying. All right, now to solve for my slant height. That's all I need, and I'm done. So 12 squared, that's 12 times 12, and I'm getting 144. Plus, I got my 5 squared, so 5 times 5 is 25. And that's going to be equal to S, there we go, but squared. There we go. All right, now I don't want to get too far down here. Let's see here. So I take 144 and I add 25, and I end up with 169. And that's equal to S squared. All right, now let's see here. Last step, I got to get rid of that little 2. The only way to do that is take the square root of both sides. And that will give me my S, which again is my slant height, your height on a slant. And I take the square root of 169, and I end up with 13. There we go. So I'm going to throw that up here. S is 13. All right. So let's see here. I got everything? The area. Yeah, I found the area of the bottom there. It's 100, so I got that. This is a 4-sided shape. Not counting the bottom. The bottom doesn't count. So I got N. The base here is the distance, a green line along the bottom. I got B and then S. I found that as my slant height. So that's 13. So I got everything. All right. Now time to substitute in. So a little bit of, we had 2 side works here. So surface area is equal to, let's see, the area there is 100. Plus N, which is 4, right? That's the number of sides. We got that. Ooh, now we got brackets. Now in brackets, I got my B. See, again, this is why I labeled my diagram, which is 10. All right, my S, that's slant height, which I found is 13. All right, divided by 2. All right. So now everything's substituted in. Now what we're looking at doing is bedmas. So brackets. Yeah, we got brackets here. We got a lot going on with the brackets. So my surface area is equal to 100 plus 4. All right, now the first thing I'm going to do here is multiply. I got 10 times 13. Anytime you have something times 10, you just add a 0, so it's 130. Okay, but I'm still not done with brackets yet. All right, so I have my surface area is equal to, let's see here, I got to do that 100 divided by 2. Or sorry, 130 divided by 2. What do I get in here? Let's see, clear 130 divided by 2. I get 65. All right. Next up in bedmas, I said brackets. Hey, there's no exponents. That's a good thing. Let's see, change color here up a bit. Let's go right to the black. There we go. So surface area, let's see, 100 sitting there. Then I got 4 times 65. I got to do my multiplying, right? And I get 260. All right, finally, saving the biggest one for last here. Adding and subtracting, well, I definitely got some adding. Well, 100 plus 260 is going to be 360. Now, what are the units on this thing? Centimeters. Everything was measured in centimeters. And again, we're wrapping up a pyramid, which, given my wrapping skills, I wouldn't even attempt to do. But if I was, I would need 360 centimeters squared to wrap that present, to wrap that pyramid present. And there we go. So little 2 side deals there that we had to do. We had to do a little area of the base, length times width. That's what it's of a rectangle. And again, a square is just a special rectangle. And then we also had to use the Pythagorean theorem again to find the slant height.